Oi, Moneypenny, stop lazing around in the hot tub and get on with some work. It's UFO Twitter week next week. You're meant to be busy preparing.
The sun is shining in England. I don't care. I do care actually. But I'm not a UFO person normally. I'm interested in the engineering, the aerodynamics, the technology of propulsion and energy. I'm not really interested in the organic little green men type thing at the moment. Maybe I'll get onto that. Except in a biological sense. I've been learning from Michael Levin. Wow. You've got to watch his videos. They're mind-blowing, mind-blowing. So he deconstructs everything down to a subatomic level. So we're talking atoms, molecules, ions, cell membranes, bioelectricity, consciousness. Now there's the big one. Where does consciousness start? If there is a little cellular organism, embryogenesis has happened. It's been created. A little cellular organism. Okay? It's got its subatomic bits, it's got its nucleus going on, it's got its cell membrane, which we know is the sort of transistor of bioelectricity. But where does that bioelectricity come from in the first place? Well, potentially a potassium ion crossing that membrane could induce it. And we know that to be true from Michael's experiments, and no doubt other people's as well. But what has he done with it? He's taken the skin cells of a frog and effectively told those cells to have another goal, another purpose, because we have to understand there is agency here. Each cell has a purpose, a goal, and it will do anything to reach that goal. So if you chop off a frog's leg or its head or something like that, the cells don't like that. That's not homeostasis. The frog needs to be able to breathe and eat. So the cells have to find a way around that to do something about it. And you'll be amazed at how good they are at getting through problems. Maybe that's a lesson to us. If it wasn't for having problems and obstacles, would we be quite so resourceful, quite so intelligent? Well, let's go back to that little cell. Now, at the moment, it might be a lonely little cell. Now, we know that that one little cell can split into 2 and 4 and 8 and 16 and 32 and 64 and on and on and on to become me or you. We all come from one cell. So why do we have the audacity to tell a cell it cannot have consciousness? Because where does our consciousness come from? We declare ourselves to have these brains that are amazing. We came from that one little cell. How did that happen? You have to look into it a little bit closer and see that one cell on its own, just like the lonely rat in its cage, is not going to achieve much at all. It is only with the support of its community, when there are lots of cells around it, all with a purpose, all given roles and distinctions and things to do, jobs that are assigned. So the cell community gets together and says, right, you group over there, you're on skin, you're building skin today. You guys, you're building an eye. Oh, you guys, the fellow lost his foot yesterday. Can you go and regenerate a new one for us? Great, go and get on with it. And so the cells are communicating. Now the cells, each cell, knows how much energy is within its neighbouring cells. So it can look at the cell next to it and go, "Oof, he had a bad night. He's not got much energy. He's not going to be much use to me. But hang on, those cells over there, whoa, they're a bit ready for work." So the cellular community works together, communicates together, talks together through bioelectricity, through communication. And those singular organisms, do you know what they can do? They can self-replicate within 48 hours to create an army of cells, if needed, to go and build something amazing, like you, or me, or this plant. What happens then? Because if the cells start replicating and building an army, are we safe? They can navigate a maze. They have a memory. They know if you change the organism in development, take one of these little planaria type worm things that Michael Levin experiments with. They have a sort of brain in the middle and a head at the top and a tail at the bottom. So you chop bits off and you encourage it to grow 2 heads. And then what happens? You'd think when it chopped it again and had the chance to rebuild, it would have a memory. I just had 1 head before, I'm sure I had 1 head. But no, the most recent form was a 2-headed planaria. So it builds another one and another one and another one and an army potentially with 2 heads. With a potassium ion, with the right stimulus crossing that cell membrane, we can change all that back again. And it'll have a different membrane together. Now that's without any DNA, genetic involvement. This is morphogenesis at a cellular level, with cell memory, cell consciousness, bioelectricity in the cell. Fascinating. If you want to find out more, go to the expert. I'm not the expert, I'm just the messenger. It's Moneypenny. Come and join me on a space soon. I want to discuss the ramifications. Don't tell Elon, but it might be